Hello everyone, welcome to my YouTube channel TechSpot. This is me, Harish Goupale. So basically in today's video, we are going to discuss about full adder and the RTL design implementation of full adder by using basic logic gates and RTL design implementation of full adder by using two half adders. As we know that full adder is useful for the binary addition. So it has three inputs. It can be A, B and carry in. Basically carry in is the previous output of addition, and it has two outputs, that is sum out and carry out. We know that sum out always computes by using an XOR gate, that is A XOR B XOR carry in, and store the result of addition, and carry out always computes by using AND gate between two inputs, that is A and B, or with carry in and A XOR B, and store the result of carry out. So based on the Boolean expression of sum out and carry out, even truth table also says that if all three inputs are low, then sum out and carry out are low. If any one input from these three inputs are high, then sum out is high and carry out is low. If any two inputs are high from the three inputs, then sum out is low and carry out is high. If all three inputs are high, then sum out is also high and carry out is also high. So let's jump to the RTL design implementation of a full adder by using basic logic gates and by using two half adders on a Vivado tool. So here you can see my screen. This is the Vivado tool. Here I have already written a Verilog code for the design implementation of full adder. We will go through each line of code. My module name is full adder. I am having three inputs A, B and carry in, and two outputs, that is sum out and carry out. I have assigned A XOR B XOR carry in to the output sum out, and A and B OR with carry in and A XOR B to the output carry out. Okay. If I click on this schematic, then it will give me the gate level schematic. Okay. Here you can see sum out is computes by using an XOR gate of between A and B and C in carry in, and carry out computes by using an AND gate between A and B or with carry in and A XOR B. Okay. To verify this code, I have written a simple TB code also. Here you can see my TB name is TB full adder test bench code. Test bench code name is TB full adder. Same inputs A, B, carry in and carry out and sum out. This is the instantiation of full adder. Okay, this is the name full adder. So I have taken an instantiation name, and inside the initial begin I have given combinations. As we are having three inputs, so total 8 combinations are there. Now if I click on this run simulation, as I already run this, if I click on this relaunch simulation, then it will give me the waveform. Okay. And in waveform we'll see the output of sum out and carry out. Okay. So if I click on this untitled, and if I zoom out this and click on the zoom in, so that will give the proper waveform. So as I told you while explaining the truth table, if all three inputs are low, then carry out and sum out are low. So you can see all three inputs are low, so carry out and sum out are low. If any one input from these three inputs are high, then sum out will be high and carry out is low. So you can see here carry in is high, A and B are low, so sum out is high. Here also you can see B is high, A and carry in are low, so sum out is high and carry out is low. And also I told you if two inputs from the three inputs are high, then carry out is high and sum out is low. So you can see that A is low but B is high and carry in is high, so carry out is high, sum out is low. Here you can see A is high but B and carry in are low, so carry out is low and sum out is high. And here you can see A is high, B is low and carry in is high, so carry out is high and sum out is low. Here you can see A and B are high, carry in are low, so carry out is high, sum out is low. and if all three inputs are high, then carry out as well as sum out both are high. Okay, now let's jump to the RTL design implementation of full adder by using two half adders. So if I click on this, here you can see Verilog code which I have already written for the full adder by using two half adders. So we'll go through the each line of code. My module name is full adder using half adder. Here also I am having same inputs like A, B and carry in, two outputs, that is sum out and carry out. Externally I have taken an wires, that is C out 1, carry out 1, carry out 2 and sum out 1. Okay, because here we are going to instantiate half adders two times, because here we are going to implement full adder by using two half adders. So first I will explain this half adder. As I have explained in my previous video, the working functionality of adder. So if you did not watch this video, then please go and watch that video. Here you can see my module name is half adder. I am having two inputs A, B and two outputs sum and carry out. I have assigned A XOR B to the sum, A and B to the carry out. Okay, now you can see my first instantiation half adder 1, where I have connect A with A and B with B. Okay, so this A with A and this B, okay, with this B, okay, and sum with sum out 1, the wire I have taken. Because why wire? Because this sum out 1 is going as an input for the second half adder. Now carry out to the carry out 1. Because why carry out 1? Because this output is going as an input to the input for the carry out. Okay, now second half adder. In second half adder, my input A is the output of first adder. So this sum out, you can see I have instantiated with this, and carry in as the second input for the half adder, and so I have instantiated C in with B, and now this is the output sum out, and the carry out instantiate with the C out to my second this is the wire C out to this wire is also going as an input for the carry out. Okay, now for the output of carry out, what I am doing, carry in, this is the instantiate with C out 1, the first input C out 1, second input C out 1, and then for output Y out. Okay, if I click on this schematic, you can see this is the first half adder which are having two inputs A and B. Now it is giving output carry out and sum. Now this sum is going as an input for the second half adder with carry in. So here it will compute C in XOR with A and B, as XOR with A and B is computed already and store output in the sum. So it will compute sum XOR with carry in, and it will store the result of addition to the output sum out. Now the output of the carry out from this first half adder and second half adder is going to the final carry output, and here it will perform the AND operation and store OR operation and store the result of carry out to the output carry out. Now to verify this full adder using half adder, I have written a simple test bench code. We'll go through this code also. My time scale is 1 nanosecond divided by 1 PS. My module name is full adder test bench. Same inputs and outputs we are having. A, B, carry in are the inputs, carry out and sum out are the outputs. This is the instantiation of full adder using half adder, and inside the initial begin, as we are having 3 inputs, so total 8 combinations can be there. So I have given 8 combinations. Okay, now if I click on this run simulation, as I have already run this, if I click on this waveform, so you can see here also you can see if A, B and carry in both are low, then carry out and sum out both are low. If any one input from these 3 inputs are high, then sum out is high, as I have told already while explaining the truth table. So here you can see A, B are low but carry in is high, so sum out is high. Here also you can see A and carry in are low but B is high, so sum out is high. Also I have explained, if any two inputs from the three inputs are high, then carry out will be high and sum out will be low. So here you can see A is low but B and carry in is are high, so carry out is high and sum out is low. And here you can see A is high, B is low, carry in is low, so carry out is low and sum out is high. Here you can see A and carry in is high, but B is low, so carry out is high and sum out is low. Here A and B both are high, carry in is low, so carry out is high. And as we know that if both all three inputs are high, then output of carry out and sum out both are high. Okay, so this is how the full adder works by using an two half adders. Okay, so in this video we saw the RTL design implementation of full adder by using basic logic gates and by using two half adders also. So if you are watching this video, then please click on this like button, and if you are new to this YouTube channel, then please click on the subscribe button. Thank you so much.